This recording is for Math 31, Module 6, Lesson 2, where we're going to be introduced to rates of change. A little bit of a pivot from things we've done before, but I think not too terribly hard. To introduce a few of the concepts to start with, I'm going to use a little sports example. Let's say that you are carrying a football and you go down, you catch the ball and off you go and you run downfield. The numbers that I had were, I'm going to run 6 meters down the field. And let's say you get tackled or you have to turn back because someone's in your way and you come back 2 meters and then, the play is dead. It's a little different in terms of comparing how far you actually made it downfield to how far you actually ran. So when we talk about the definition of speed versus the definition of velocity, there's a little bit of a difference. So if we look at this example here and we talk about the total distance that you carried this ball was carried 6 meters down and then 2 meters back. You went a total of 8 meters in this example. But how far downfield you are in terms of your actual displacement, you're only 4 meters downfield from where you started. So the line of scrimmage, again, if you're a football person, you'd be back over here. So you have to be cautious about the total distance that you went versus how far you actually ended up from your starting position. That helps us with our definitions of speed and velocity. So our definition of speed is that we take the total distance traveled and we divide it by the time. However, velocity is the displacement of the object, in this case, you carrying the football, divided by the time. So we have to be a little cautious. I know in real life, there's no real change in our language versus using the word speed versus the word velocity. Here we have to be a little cautious because we're, technically looking at the math. So that's one little side note kind of to get us started. Now, before we get into an example, I've got a couple examples planned here for us. We need to look at all the different variables that come up and know how they relate. So the variables that are going to be present in this section are T, their S, their V, and their A. Okay, T is like our X. T is time. And we usually have a variable statements that look like this, say y equals 2x squared plus 6. In this case, we're going to have statements that look like this, 2t squared plus 6. Now, be careful with S, okay? S is not speed. S is our displacement. So we have to be really careful. Don't know why they don't use a D, but they don't. So we have to be cautious of that. So it's sort of like our Y, in terms of trying to relate it back to when we would do derivatives. Then velocity is the derivative of S. Okay, so it's S prime, or we could write it as ds over dt, whichever way we would like to do it. And then acceleration is the first derivative of velocity or the second derivative of displacement. So we say that, okay, we've done first derivative here to get from displacement to velocity, and then we do the second derivative here to get from velocity to acceleration. So it's S double prime or D squared S over DT squared. I think I got my squareds. I don't know if I have my squareds in the right place down here. Where do we put it? No, I think I had it right. Or it could be thought of as the first derivative of velocity. So we could have dv over dt. Okay, so it's like we've got this function. We take the first derivative, we get velocity. We take the second derivative, we get acceleration. If we're given a velocity statement, then of course we were doing one derivative to get to acceleration. So just to relate back to things that we did in module 3. Okay, let's blast off into example here that I've got pre-prepared. I will just take a second to get the image up on the board here for us. And then move it down in place. And I'll tell you where it is if you want to have your instruction booklet open. And so this is from page 38. Example 2. And it's not numbered, but lettered, but I'm going to do this just to make life easier for you to follow along with the explanation as we go through this question. Okay, so we've got this particle, sort of like the football example. This one's a quadratic. You can see 2t squared minus 8t plus 10. Nonetheless, we have a particle moving along a number line from point P, 10 units to the right of the origin, and then they give us this displacement example, and they ask us for a number of things. So first thing they ask us for is average velocity between t equals 3 and t equals 5. Average velocity is like asking for the slope between these points. So we take our statement. We need to find the value of s when t equals 3, the value of s when t equals 5, and then do a slope calculation. So let's do that. Okay. So we have at t is equal to 3. We have s equals 2 times 3 squared minus 8 times 3 plus 10. Work that out. And then we find at t equals 5. I'll write this down. 2 times 5 squared minus 8 times 5 plus 10. Get your calculator out. Again, you can always pause the recording if you want to get your numbers before I throw them up here. This is 20. So we have the one coordinate 3 and 4. We have next coordinate 5 and 20. Again, if you don't remember the slope formula, because there's so much that interacts in this course, so you have to go back and pull out from your memory banks. Here's the formula. We throw our numbers in: 20 take away 4 over 5 take away 3, 16 over 2, we get 8. Now let's go back and have a quick little boo at what our units were. Pretty important in this module that we're conscious of units. And so it says this is displacement. Oh, it doesn't even tell us units per second. Okay, so if it doesn't tell us like meters, centimeters, then we just say, okay, it's units per second. Okay, so we just put the word units in. So that's how you do the average, just a slope calculation. Then it says find the velocity at any time t. So just remember what I just mentioned, that when we're doing velocity, we take the displacement equation and do the first derivative. So simplistic math when you know what it is you have to do. So you drop the 2 down in front, subtract 1, so you get 4t, and then minus 8, and the derivative of the 10 is 0. Okay, so that's a nice easy one. Find the velocity at t equals 6. Okay, again, this is a pretty nice easy one. You just take the velocity statement, throw 6 in, 24 take away 8, you get 16. Again, we have to be careful here. It's units squared per second. Okay, so velocity has square units, not just regular units. What's the next thing it says? Find the minimum value of S. Okay, minimum values. Now we've done maximum minimum values in module 5. Remember when we're talking about graphs, the minimum value would be where the graph came down, stopped, and went back up. Hopefully you remember that the value of the derivative at the minimum value is 0. Okay, the value of the derivative is 0. So that means at the minimum value, velocity equals 0 because velocity is the first derivative. Okay, so take the velocity statement. 0 equals 4t minus 8. Then to solve it, you get 8 equals 4t, t equals 2. And the units for that is 2 seconds. Okay, so now I didn't want the point, find the minimum value. No, just to find the minimum value. So at t is equal to s, we have, when t is equal to 2, we have a minimum value. Then we actually have to go find that minimum value. So we have to go back into the s formula. I'll just keep writing it because the board scrolls. We put 2 in there, 2 times 2 squared minus 8 times 2 plus 10. And so our displacement, again, I always want to say speed. So if I say that, I apologize. And so we are actually 2 units downfield, or 2 units over. Okay. All right. I think there's only a couple. Sketch the graph and describe the motion. Okay. So this is a nice, easy graph to sketch. I know that we're really technically not supposed to have our calculators, but we can do a quick little sketch here. We already know a number of things here. So be cautious when you're doing these questions to sort out the real values. It did tell us, and this is a little detail I didn't even mention, but you notice that it tells us that the domain as x is greater than or equal to 0. Do watch those things when we work on your graphing or any questions that you know what the domain is. So this particular graph starts at 0 and 10. That's our y-intercept here. And we just found our minimum value, okay, was at 2 and 2. And then it kind of goes on forever. So it's this parabola that starts here, whoops, comes down, and then goes up like that. So that would be it graphed on a kind of a 2-dimensional where we'd have this to be t and this to be s. It's not really quite what it asks. The question asks, I'm just going to read it from the booklet, sketch the graph and describe the motion. Well, the sketching of the graph is okay, but describing the motion. Think about, and again, maybe pause the recording and think about what does that mean by describe the motion of the particle? So it might be easier if you get a question like this in the assignment to do it on a number line and think about what's happening to the particle. So if we have this at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it starts here. Here's where your particle starts. Okay. And then it decreases down to 2. So it goes this way. Okay, to 2. And then it obviously turns and then goes back this way. Okay, so it's decreasing for this first section. Again, I can do some color coding, some highlighting, which is this section here. And then it turns like this and goes back this way. Okay. So that's one particular way. We could also put some time. So at time t is equal to 0, it's at 10. T is equal to 1, we didn't actually find. 2 minus 8 is 6 is 4. So at t equals 1, we're here. At t equals 2, we're here. Then it turns and then off it goes. Okay. So that would be how we could describe the motion of the particle. And there was one more question. What did the last one say? Find the total distance traveled in the first 4 seconds. Aha. So let's do a little bit more to this diagram then, because then we'll have our numbers. So at t is equal to 1, it's at 4. I'm just going to throw that there. And then we have t is equal to 3 seconds. Let's go find that. So, oh, we already had it. We already had it up here, didn't we? At t is equal to 3, we're at 4. Perfect. So at t is equal to 3, we're back here. And then t is equal to 4, let's do that one. So 2 times 4 squared minus 8 times 4 plus 10. So 16, 32 minus 32. I think we're back to 10 again, aren't we? Yeah. So back up here at 10. So then the question said, we want to try to find the total distance traveled. Find the total distance traveled in the first 4 seconds. So then, let's write this down. Total distance in first 4 seconds. Okay, so when we do this question, we have to be a little cautious. We have to add the distance in one direction and the distance in the other. So we have to break it in from t is equal to 0 to t is equal to 2. That's our turning point. Find that distance. So s is equal to, at 2, we were at 2. At 0, we were at 10. 2 take away 10 is -8, but we're looking for distance. We take the absolute value. It's gone 8 units from 10 down to 2, right? We don't care about direction. We just care about how far. And then we go from t is equal to 2 to t is equal to 4. So again, do the absolute value, just be careful. I don't think this actually matters. So you're at 10 and you were at 2. Absolute value of 8 is 8, and we add them together. Okay, so the total distance is 16. And then again, there were no units, just put 16 units. Okay, so introductory example shows you a number of things. We did average velocity, we did instantaneous velocity, which is the derivative. We looked at the motion of the particle, total distance traveled, a number of things. Okay, second question that I want to do comes from the booklet, page 60. So I'm jumping down here to remind you of something. Again, another process that gets applied here, implicit differentiation. So we're doing example 2 from page 60, and it reads this. If v squared equals 4s squared plus 200, and I'll write down what all the words. It says where v is velocity of a moving object, and s is the distance from a fixed point find the acceleration. Okay, so let's just remind ourselves, because this is new, that t is kind of our base value. S is something to do with the t over here, right? And then velocity is ds dt. And acceleration is equal to the second derivative, or in this case, it's going to be more important to know that it's the first derivative of velocity. So this is an implicit differentiation question. You remember those questions where we had something like, just as a reminder here, 2y squared minus 3xy equals 7. Let's just say that was a question. The reason this is implicit differentiation is because we couldn't isolate the y. We couldn't get it to read y equals with the x's over here. And so we had to do each individual term. So same thing here. We have to be cautious that when we do the derivative, we're doing the derivative with respect to t, right? That's our kind of our base value. Last modules, we've been doing that. Value on the right-hand side is our x coordinate. This time it's a t coordinate. So we're going to go dt, d dt of each term. So d dt of v squared equals d dt of 4s squared plus d dt of 200. So you do each individual one. Now this is where the chain rule gets implied, because we have to do the derivative with respect to the letter that we're talking about times by the derivative of the letter we're actually doing the derivative of, which is t. Okay, so not a terribly hard one, I don't think. You do the derivative of v squared, which is 2v, and then use the chain rule. So we have dv dt in the back. Then we do the derivative with respect to s. So we get 8s, and then it's 8s, and I write a c, sorry about that. So we get 8s ds dt, and then the derivative of a number is 0. Now, easiest is this point to replace dv dt with a, and replace ds dt with v. So then we get a kind of a nice looking expression, 2va equals 8sv. And now we're trying to find acceleration. So we're trying to solve for this. So simply divide both sides by 2v. So we get a is equal to 8sv over 2v. And then we just simplify it and things cancel and we get 4s as our answer. Okay, so might have looked like a tough question, not sure which perception of it was, but we just do the implicit differentiation of each term and then solve for a. So hopefully you find this helpful in completing module 6, lesson 2.